Solving a triangle with the law of cosines. Once again, we're going to be looking at the case of an oblique triangle, a triangle which does not contain a right angle. We looked at using the law of sines to solve ASA, AAS, and SSA triangles, cases where you have a situation with an angle and the opposite side both known. In this video, we're going to be looking at the SAS triangle and the SSS triangle, the two cases where it is impossible to get a side and the opposite angle both known. I'm going to specifically look at the SSS case in this video, but I think that once you've seen it, the SAS case is going to be very apparent. So the law of cosines is a generalization of the Pythagorean theorem. C squared equals A squared plus B squared. That's looking familiar. And then we introduce this one more term, minus 2AB cosine C. And we can use this and switch around to any angle that we want to know. A squared is B squared plus C squared minus 2BC cosine of A. Right. The two sides that show up in that last term are the two sides that show up on the same side of the triangle, and the angle that shows up in that last term is the angle that shows up on the other side of the equation. And then for completeness, we also have B squared equals A squared plus C squared minus 2AC cosine B. We almost always write the law of cosines using that first form, but you can use this for any shape of triangle you want. You can use it for solving whichever angle you want to solve. If you're looking at a triangle that is in the SAS form, that means that you know everything on the right-hand side and you can solve and find that third side very quickly. When you're dealing with a triangle in an SSS form, you don't quite have that much information, and it's going to take a little bit more work, but not that bad regardless. Let's take a look at this triangle. Let's call it triangle ABC because we're lazy and that's what we do. And let's fill in some values of, say, 58 here, 71 here, and 46 down here. The first thing you need to do with an SSS triangle, the SSS and the SSA triangles are the only two cases where it's possible to not actually have a triangle. And what you have to check here is that no one side of the triangle is bigger than the other two combined. This particular triangle is not a problem. But before I solve it, let's change this slightly and say that that bottom value was, instead of 71, let's make that 126. Thinking about this spatially, to go from A to C is 126, say, inches. Or you could take the long route of going up to B and then from B down to C. And that's 46 plus 58, which is 104 inches. So taking the long route saves you 22 inches. If that makes no sense to you, I agree. This is not a triangle because 46 plus 58 is less than 126. Your biggest side is bigger than the other two sides combined. When that happens, you do not have a triangle and your work is done. So with that corner case out of the way, let's take a look at the case where this side was 71. This triangle does satisfy the triangle inequality, so it will be a triangle and we can solve. We have 3 angles in the triangle to look at. We can pick any one of them. It's natural to decide to start with C because the equation is already solved looking at angle C and we don't have to do any rewriting. So I fill in all the information. C is 46. A is 58. B is 71. A is still 58. B is still 71. And I don't know what C is. I can do some quick number crunching. 46 squared is 2,116. 58 squared is 3,364. 71 squared is 5,041. 2 times 58 times 71 is 8,236. Let's do some subtracting to get the cosine term by itself. And then divide. Let's copy this onto a clean sheet so I have room to work from there. Let's just go ahead and copy that there. Divide both sides of the equation by negative 8263. So I get this value somewhere in the ballpark of 0.761. All right, here's another place that you can check to make sure your triangle actually exists. Because if this value is between 0 and 1, your triangle exists. If this value is smaller than 0 or bigger than 1, your triangle does not exist. But I can take the inverse cosine of that value, and my calculator is quite happy to tell me that angle C is 40.4 degrees. All right, coming over here and grabbing the rest of my triangle. With that information, I now have enough detail to fill in however I'd like. Right? I now have this situation of angle and opposite side both known, so I can go back to the law of sines and use that to determine the values of the other 2 angles. Because I have all 3 sides of the triangle known, I'm not going to run into any weird problems of triangle not existing or there being 2 possibilities for the triangle. I do have to worry a little bit to make sure that I don't have an obtuse angle somewhere in here, but I have all 3 of the angles of a similar size. I could also continue using the law of cosines and just work my way through and use the law of cosines for angle A and use the law of cosines for angle B. Both options work. This video is getting long enough. That's the basic idea of how to apply the law of cosines formula, get a value out from it. I'll leave the rest of solving this triangle for your own work.